is my power series, basically the geometric growth formula, okay, which if we just look at it as a series, we call it a power series. And that power series is just going to be 1 plus x squared, x plus x squared plus x cubed plus etc. And for as long as the x's stay between negative 1 and 1, so that's x represents our common ratio, it will mimic this 1 over 1 minus x function, because this is our infinite geometric growth formula, essentially, okay, when our starting value is 1 and our x value is our common ratio. Okay, so as long as the common ratio stays between negative 1 and 1, notice what happens. So I'm just going to, down here is going to be my series. Okay, so I've just got 1. I'm going to get the next term here. Oops. N equals 1. Okay, so that was n equals 1 here. So notice that at 0, it's just tangent there. And only places this curve is, this purple line is anywhere close to this line is just at 0. Okay, so, but as we increase this power series, and we just use the next portion of this power series, okay, we get this function here. We get this quadratic function, and if you look closely, it's fitting the curve a little bit better here. Still not that great because it diverges right away. But between negative and 1 and 1, that's really all we can expect it to be good for, because it doesn't converge beyond that. So remember that diverging series are no good to us. But as I increase the number of terms, notice between negative 1 and positive 1, that, and I'm going to zoom in a little bit here, that fit is not too bad. Okay, and if I go to one more term, okay, between negative 1 and positive 1, yeah, that's not too bad. I go to another term, and again, notice that the fit is getting a little bit better, a little bit better, a little bit better, a little bit better. And as I increase the number of terms, the fit onto the curve of that reciprocal function, this polynomial is starting to fit that curve quite nicely. It only fits that curve between negative 1 and positive 1 because, again, our radius has to, our R value, our common ratio has to be between negative 1 and 1 for an infinite geometric series to converge. And so beyond the convergence zone, it just no good. It just totally diverges. But within the convergence zone of the radius, the common ratio being negative 1 to 1, look what's happening. So it's getting closer and closer to that curve. So it fits that curve better and better and better. And this is the whole idea behind why we're going to look at these series. And this is what we look at when we look at series as a function. And that's what we're eventually going to do. We're going to look at these series and put them together with these power series, these x power series. Okay, so these x powers are what we call power series. They're not part of the sequence. But we're going to put our sequences with these power series, and we're going to use these to actually represent functions. And that's what we're looking at down the road.